So what's the derivative of the exponential function e to the power of x? That is a question with a very simple answer. E to the power of x turns out to be the only function that is its own derivative. Okay, that would be a short video if we ended it here. So let's talk a little about how this interacts with the chain rule. It's quite common to have the exponential of a function. It's most common to have the exponential of a very simple linear function like 5x. But whether the function up here is simple or complicated in terms of the chain rule, the exponential function is the outside function, and the function up here is the inside function. So if we wanted to take the derivative of e to the 5x, what's the chain rule say to do? It says to take the derivative of the outside function. Well, e to the x is its own derivative. To stick the inside function inside of it. So e to the 5x, and then to multiply by the derivative of the inside function. In this case, the derivative of 5x is 5. So 5e to the 5x. A slightly more complicated example. Let's take the derivative of x times e to the quadratic x squared plus x plus 1. Although I've called this slightly more complicated, and it obviously is, it requires the product rule. We just need to keep calm and do things carefully and in their correct order. So we start with the product rule. We've got one function, x, times another function, e raised to this quadratic. The derivative of x is 1. We leave the other function, the exponential, alone. So 1 times e to the x squared plus x plus 1 plus, and now we leave the x alone. And we need the derivative of the exponential. It's going to go very much like the first example we did. The derivative, so again, the exponential is the outside function. This quadratic is the inside function. So the derivative of the exponential is the exponential. We stick the inside function inside of it to get e to the x squared plus x plus 1. And then we multiply by the derivative of the inside function. And the derivative of x squared plus x plus 1 is 2x plus 1. And then, I guess we could rewrite this a little. There's a common exponential. We could maybe pull that out if we were so inclined. So what we have is e to the x squared plus x plus 1 plus x times 2x plus 1 times e to the x squared plus x plus 1. And I'm often a little dismissive of simplification because I think simplification is a lot more subjective than textbooks often pretend. Like what's simplified or what isn't simplified depends on what we're trying to do. But since I floated the possibility of simplifying this, we could take this e to the x squared plus x plus 1 term and we could pull it out and we'd get a 1. And here we'd get a 2x squared. And we'd get an x. In any event, this is the derivative of x times e to the x squared plus x plus 1.